today we're going to be digging in and getting familiar with the code to be a better tester. A little bit about me. Like, I don't know if I have to really say anything. Teresa gave me a great intro there. So I'm a senior software engineer. The in test is implied. It's not part of my title anymore. It used to be. They took that title away, whatever. And Friday is my last day at the Rocket Family Companies. I'll be starting a new job on Monday, but I'm still going to be working remote, still near Detroit. And that is my family there, my dog Cooper, my husband, and me, just checking out squirrels across the street, I guess. All right. Oh, so a quick story. A long time ago at a software company far away, forever ago, it feels like, I worked with a bunch of software engineers that wouldn't talk to me because I was a tester. You know, they have that kind of ingrained thing. So I found myself missing things entirely because I wasn't focusing in the right places. I was testing what was in the requirements document that I got from the BA like 6 months ago. And they had been meeting without me and then changing the application, what it was going to do. And just, I was left out of the whole process. I felt like totally separated from everything. Like I'm just somebody they keep around to yell at the end of the release cycle. I left that place after not too long because it was just kind of a toxic environment with new teams and new technologies to work on and newfangled agile technology or methodology. I felt more in tune with what was going on. And I was working much more closely with the software engineers and learning about the tools they use to communicate what their code is doing with each other and with the organization as a whole. I started getting emails from source control with notifications of changes, pull requests, all kinds of stuff. And it felt really strange to have information sent to me without me having to ask for it. So I started digging in for more information because I was like, oh, this is like a treasure trove of information. Today, I want to show you some of those areas where testers don't often venture, but we really should. We're going to talk about a couple of specific areas where you can dig in to what's going on in the code of the applications you're testing and see how these can help you find some bugs. So we're going to look at commits and PRs, static analysis and code coverage, dev tools, and some other tools. But I want to make clear that for this talk, you don't need to learn how to code to get a lot of information from the code. I know that not everyone wants to learn to code like a software engineer, and that's okay. I feel very strongly that we should learn about the code so we understand more about what we're testing as much as we can. It is, after all, the thing that makes up what we work with every day, so we should kind of know as much about it as we can. So first, we're going to take a look at commits and PRs, but to get into those, we need to get into version control. So version control, and I apologize for the people that are already up to speed and know all about this stuff, but we need to do some level setting for those of us that may not be as familiar. So basically, version control is what saves our butts in software development. If things go wrong, like your computer crashes, your code is saved in version control. Someone writes buggy code and pushes it out, we can go back to the previous version until they fix it. Or if someone's working on a feature, then they go on vacation or win the sweepstakes or something like that, and they leave, or your laptop, like mine, I've had so many laptops just blue screen and be totally unrecoverable after that. Version control has saved me. All of my code that I was working on is not lost. So version control, there are many different types of systems out there. Git, GitHub, TFS, Bitbucket, Subversion, Mercurial, CVS, there's a bunch of different ones. And I'll be using terminology from Git for this talk because it is very common and it's free to use, so you can dig into it outside of work if you want. And the terminology that you may encounter may be a little bit different, but the concepts should be as similar, very similar. That is, unless you have no version control at work. Well, I don't know what happened to that animation, but that was gone. So if you have just a bunch of folders on a developer's desktop, then run screaming as fast as you can, because that is terrible. So why should you care about version control if you're not in the application's code every day? Because that's where the code you're testing lives. It has many secrets hidden in plain sight. For instance, we're going to take a look at some commits. So these are commits in GitHub from obviously when I wrote this talk in 2018. Commits are smaller groups of changes, usually from a day's work or less. Hopefully commits are happening multiple times a day as people are working. And you can see all of these from under August 11th. Clearly my stuff is going great here, but I was having, multiple things I was trying and checking things in. But we can see that the changes themselves, we can see what's in the changes themselves. So even if those messages aren't that great, like clean up unused stuff, I can kind of dig into it and see what code actually changed. So pull requests, or PRs, as they're commonly called, are groups of commits. It's called a pull request because you're saying, I request that you pull in my changes to the main branch. So here's how that works in general. You have the master or main version of the code base, generally what's in test, beta, production. Then you have your fork or the branch that you're working with. And then you have your commits, all of the commits that you're coding all your stuff, you have your commits. And then when you're ready, you feel like it's good, you submit a pull request. So that groups all of those commits together. And then it gets reviewed. And then it gets merged back in. So now your changes are in the main one. So before the merge happens, your changes don't exist out in test, beta, production. They're not in the main branch. They're just kind of existing in your little world. And then those PRs kind of get grouped together into a release generally. And then they get deployed out to test environment, beta, prod, whatever. It depends on if you're in a CI/CD environment. Ours, as soon as we get merged, they go directly to test. But then we group them together to create a release to production. So with these, we don't have to look at commits individually because that can be a lot of changes, a lot of just kind of, and it doesn't give us the bigger picture. So we can look into PRs more. So here's an example of what a PR might look like. The application that I'm using for this, I'll link to it at the end, but it's in my GitHub. It's a to-do list, very simple to-do list application. This is a PR for a simple change to a markdown file. And this is the only commit. And it's still open, which means, okay. It's still open, which means it hasn't been merged quite yet. So it's green, it has merged this pull request, it's not ready to go yet. Oh, my animations are crazy. So I can see the file being changed in the Files tab. Like when I click over to the Files tab, these red lines are things that have been changed or removed. We can see this one was shifting up a line just from 18 to 19, like it just kind of, or shift down a line. And all the green is brand new stuff. You can see the changes a bit better in the split view. I like using the split view better when I'm looking at pull requests, so we can see the before on the left and the after on the right. So this is just a markdown file. What does that really matter? So this is the repository's README file, which tells other people how to use this stuff. It's our documentation really for how to use this specific repository. But there's not a ton there, so let's look at an example with code so we can see kind of what I'm talking about when I want you to look at the code. This is from an application that has an API and a web page. So here's the description of the PR. It says we've added swashbuckle to handle Swagger and dockerized everything so it can run on Linux, which is great. These are the commits that make up the PR. And from reading these, we see that something changed for the Swagger documentation. We're now requiring a header for all requests, which the UI auto-generates. And we have Docker support added. So one thing conveniently forgotten from the PR description is that we've added a header that we're now requiring, and the UI will auto-generate that. So hopefully the developers you're working with have commit messages that kind of explain what the changes are properly. And they summarize it well in the PR description, but sometimes that doesn't happen. So other things that you can look for to kind of fill in your knowledge. So from the utils.cs, so this is all C#, from our utilities class, I see we're removing unused using statements, which usually doesn't have any detrimental effects as long as it builds. Generally, that's okay. I can see from this, we're adding a method that checks the header of the requests to the API and see if the key can access is there. So we see this whole method is brand new. It's green. It has these pluses. That means it's totally new. So it is, if the header contains can access, no matter what the value is, we're going to say, go ahead, or they can access it. Otherwise, it's false. And there are changes to this file, which is a controller. So controllers tell an API what to do. And here's that header again. So we're checking the return from that. If a person is not, so the exclamation point is not can access. So if they can't access, basically, then we return unauthorized. If they access via the API directly. So this isn't from the UI, this is APIs. This is the controllers from the API. So knowing that this application has a web page, I can look to see how we're letting the web page access the API. Remember that commit said the UI auto-generates the header, so we can look to be sure that it does. So this is our main JavaScript page for the site. And we can see that we're setting cookies for some reason, which that's not, we were looking at headers and not cookies. And then we're adding a request header here. So set request header can access is true. So we're adding that header there. But this cookie thing is really weird. Do we really need that there? This is like extra stuff, and we didn't talk about cookies, and it looks like somebody copied and pasted and maybe abandoned this code and forgot to delete it. So that code actually is old code. It shouldn't be there. I can add a comment in the context of the conversation by clicking on the plus sign that's right next to the first line of the code that I want to comment on. And then it will give me this little conversation thing, and I can type in a comment in the context of that code. That's really helpful so that you don't have to say, so in this one file on this one line that I think maybe something's wrong, you can just say right in context. And it's good for me, what I like to do is review the comments from other software engineers to see how they're talking about the code that's there. Okay, so what else can I do with this information? Why do I care about PRs? What if one of these set request header functions had can access spelled wrong? That's a Q where the A should be. That's a Q. Q and A are really close to each other on the keyboard. Very easy to make that mistake. So is this going to cause a problem? Yes, because the header has to contain a key can access it. It's case insensitive, so that part doesn't matter. But a Q is definitely not an A. So it will cause problems. They will have access issues. So someone in the get data, this is in our get data function, which is how our list of to-do items populates the main page of our website. And we'll kind of go into what happens if this gets through. But this is something that we as superpower, our superpowers as testers is an attention to detail. This is something that we can kind of find that other people will just kind of skip over sometimes. But what happens if this gets through? Nobody noticed it. So we merged that. We start testing. It's in test. We start testing. Right away, we have a problem because we can't load the to-do item main page. So because that header is wrong, we don't have access to the database or the API, so it's not working. So to troubleshoot, we can try that request with Postman using the new headers that we know about because we always communicate really well with our developers, and that request works fine. So we go back to the website, maybe using DevTools, which we'll talk about later, to see what the issue is. And then there we can see that it's getting an unauthorized back from the API. We can dig into the request, and we can see that misspelling from there, maybe. We can look through the commits to see who made the change. So Git has this thing called Git blame, and you can see who made the changes. I really don't like that whole blame thing, but you can at least talk to the person that wrote it and show them, oh, this is, you know who worked on it, so you can have them fix the issue potentially. Now we can turn it over to a software engineer who has already started working on the next thing. So she'll need to stop working on that, create a new branch off of master, and we start over again. She's got a branch or a fork. She's got a commit. She does PR. After that gets reviewed again, it gets merged back into master. Then we deploy back out to the test servers. We can start testing again. So we potentially lost a few hours, maybe a day or two. If you're really unlucky with the timing of everything, maybe it's a weekend or whatever. If we would have caught that before the PR was merged, the software engineer could have made the change very quickly and committed the change, which would add it to the same PR before they context switch to the next task. So that's potentially minutes rather than hours. So this is obviously a very simplistic scenario, but things like that happen all the time. Like I catch dumb little things like that in PRs often. So it's not really misspellings, though. I do have one developer who's dyslexic, and I help him kind of with spelling stuff. Once it gets to the PR, he's like, "Can you check for spelling?" And then I, add comments for things that need to be fixed. So it's very easy to do it there rather than once it goes through all the whole CI process and it gets to the test environment, and then he's got to get back and make those changes. So it saves time for everybody. So why care about any of this? Shouldn't the devs be catching these things? And yes, they should. But here you can learn about and understand the changes that are being made firsthand. You don't have to wait for someone to tell you what they did. You can see it for yourself and you can understand all areas affected by a change. This takes time. It doesn't start right away. You don't go to the repo for the first time today and know everything that's going on. It's going to take time, but spending more time in it, you'll familiarize yourself with it and you'll get more comfortable with it. They get you more familiar with the code base and the code that you're testing on a day-to-day basis. The more familiar you are with the code, the more information you have when testing. It can save you and your team time by catching issues while the dev is still in the mode of working on that feature or fix. And make sure you and the devs both understand this is not an issue with trust. This is giving you more information so you and they can have more informed conversations. Some developers or organizations say, testers, QA, whatever, should not be able to look at the source code. Why do they need access to the source code? It's more information. It's not like, haha, you wrote this wrong. It's, oh, that's information that I needed. This is probably going to cause a bug, just FYI. So let's save some time and get that fixed. So How do you see these? How do you see commits and PRs? Get any and all required permissions to view the code base or code bases, and learn about the version control system you're using. Look for videos on YouTube of how to get around it, how to use it. YouTube has like everything, especially for more popular ones like GitHub. Start to get involved in the PR reviews and code reviews in general if you're not already. Learn about what the developers are actually doing with those requirements. Are they looking at the acceptance criteria when reviewing each other's code? So if one is committing or submitting a PR and saying this is for this feature, how are they verifying that the feature is meeting the acceptance criteria before they say approve this PR? Are they just looking at the code, like is the code good to go? Or are they actually looking at the requirements? That could be your in to being part of the PRs and code reviews. And tread carefully if you feel you need to. Some developers will still be skeptical that you want to see their code or sit in on code reviews just to make fun of them. You just want to understand the code better so you can test better. It's a win-win for everybody. Just be tactful when you find bugs. Like this is for anybody. Once you write code and someone finds a bug in your code, you understand how fragile that can make you feel and vulnerable. Like I've been working on this for a week and I missed this one thing, like, oh, so just, have some empathy there. Static analysis. So static analysis is examining the code without executing it and providing understanding of code structure and ensuring the code adheres to industry standards. Technically, as testers, we do dynamic analysis of the code when we're running the code. We're executing it, so we're putting it through its paces in dynamic analysis. So this is just static analysis. The JSLint help file had this great explanation of what static analysis tools do. JSLint is a static analysis tool. They don't prove it's correct, but can help spot some potential problems. There was a mention earlier. Oh, no, sorry. That's from different notes. So let's talk about static analysis for the application code. This is not for automation code, just for application code. There are a ton of tools out there to do static analysis. This is the listing from Wikipedia for every static analysis tool available. Clearly, we're not going to cover all of them. See if I can run through that again. Yeah, tons and tons of tools. Mature or progressive organizations will have a tool or multiple tools set up. These give lots of shiny metrics. Management loves metrics. And yes, they can be abused. Something to keep in mind. Like any metrics, these can be manipulated if someone feels the need. They're also not 100% accurate. These tools use generally accepted rules to assess the code. So they're not like absolute going to show you bugs or not in there. Some types of issues. So we're going to be using SonarQube. I don't think I mentioned that. So we're going to be using SonarQube because that's one I'm familiar with. It's open source and it supports a lot of programming languages. So you could actually pull it down yourself and try it out. So the types of issues that SonarQube kind of covers are cosmetic. So we don't really care about these. These are like tabs versus spaces, semicolons or no semicolons in JavaScript, the preferences that devs have that have no effect on the code whatsoever. Code smells. So the code, it technically works, but it's kind of wonky. It could be better. These relate to how maintainable the code is, if it needs to be changed, when changes are made. If there are a lot of code smells, that could mean more incidents of bugs. Bugs are determined by the static analysis tool as issues with the code that, if not seen as broken now, it probably will show up as broken at the worst possible moment, so fix it soon. And then vulnerabilities, which are security concerns. So, any kind of security concern that it can scan for. So the information we can get from a static analysis tool could help us find those bugs and code smells we may not otherwise see. I've used our internal static analysis tool to pinpoint my testing in areas that looked a little bit more sketchy to find legitimate bugs. And I've seen teams set up their static analysis, then kind of ignore it. But static analysis is a playground for us as testers. I have a whole other talk on static analysis for testers and the treasure trove that it is, specifically with SonarQube again. So just I'm a big fan of static analysis personally. So this is a screenshot from SonarQube. It supports a ton of different languages, and we use it in my organization because it supports, and it's extensible as well. You can write your own kind of stuff. So we can see the bugs identified, code smells, code coverage, which we'll talk about in a minute. I have kind of a rant on code coverage. If we click on the bugs, it'll take us to a detailed list of what's wrong. Sorry, my slides are wonky. There's also code coverage and then duplications. So we click on the issues list, the bugs list. This is what the issues list might look like, with lots of information that SonarQube determined based on the code itself and the code's metadata. We may need to weed through some of the info here, but we can easily find issues where we can focus our testing to get these issues fixed. Ones we can ignore generally are style ones, like remove these useless parentheses, like I don't care about that. That's not going to cause a bug. And look for more interesting ones like duplicated blocks of code. Expanding any of these bugs in the listing will show us the exact line of code in the file where the bug exists. And that's another way and reason to get more familiar with the code that you're testing, and we'll kind of dig into that in a second. So this one is interesting, or no, this isn't interesting. I'm sorry. This is one of those ones that we can kind of ignore. Remove unnecessary things. We can ignore that. This one is kind of interesting because it's a security hotspot. Security hotspots in SonarQube are potential security issues, but they're not marked as a specific issue because they don't really know if it is or not. So make sure they see, the static analysis sees that there's some command line arguments. Make sure that you're using them safely so you can kind of dig into that. And then some duplicated code down here. We can see, so duplicated, we'll kind of get into duplicated code, but we can see more of that by clicking through the duplications from the dashboard. And then when you click on one of them, it will actually show you the code in context. So it will actually load up that file. So here's that utils.cs file, like we saw in GitHub. It actually loads up the file and it sees that this is not even used. These aren't used. So you can get rid of them, which is kind of cool because it takes you into the code in context and you can see all kinds of information. And there's a lot of things that you can do around static analysis that will help us kind of get more information about the code that we're testing, again, without having to load the code up on our own machines. This is, something that'll be available for the organization. So why should we even care about this? Again, shouldn't the devs care about this more than us? Yeah, they probably should, but we can learn about the health of the code base and how our devs treat their own code. Let's see. If we have automation code, we can actually use static analysis for our automation code as well. It gives us visibility into bugs or issues we may not see otherwise. So I wouldn't know that there's duplicated code that could potentially cause a bug if there's a bug in one of them and they fix it, it could be fixed in one spot and not another. So that bug could still exist somewhere else in the application. It gives us warnings for potential issues. We'd be silly to ignore them. Like if you know that there's security vulnerabilities in your application and you're kind of ignoring them, then that's kind of silly. With code smells like duplication, we can see potential issues before they happen. So like I said, certain functions are duplicated when one has a code fix. Are they fixing both things? Are they refactoring so it's not duplicated? The SonarQube gives you an idea. Let me go back to here. So for this code, it has a maintainability score of an A. So it has about 1 hour of debt, of technical debt. So SonarQube estimates it'll take about an hour to fix all the maintainability issues. There's 13 code smells. The latest check-in had 30 minutes of new technical debt added. That's bad. If there was only 30 minutes, we doubled the technical debt added and added more code smells. So that's another way that SonarQube kind of helps you see what's going on. For the security vulnerabilities, it doesn't have like full security testing because that's another dynamic analysis kind of thing. But there are other applications and things that you can use to do kind of static security analysis, but it does give you some kind of ideas for some common vulnerabilities. Code coverage. This is a thing that I get on a soapbox often about. We can define code coverage by saying it's the measure of how much of the code is executed when unit tests are run. Or what I think why we really care about code coverage is how much of the code is not unit tested. So essentially how much of the code has not been checked prior to it getting to us as the testers. But we must be careful with code coverage because it is not how high quality the code is. A lot of management will take that code coverage 80%. Once it's 80%, there's no bugs in this code anymore. I have bad news for you. So let's look at some actual unit tests to see what I mean. So this is a test that creates a new item to use within the test. So this is a new item. It's an instantiation of this class. So it creates an item and we set the name to blank. And then we call this method is item name valid and send the item. So we're checking, is the name of this item valid? So we're just, as a unit test, you're checking internally. So you're not making external calls, you're calling internally to the methods. And this is another test that is doing the exact same thing, except you'll see it has this assertion at the bottom. It's actually asserting against the result of, is the item name valid? So that first one isn't actually checking anything. It's just making the call. It is checking nothing. The worst part is both of these pass because in unit testing frameworks, if you have no assertions at all, it passes. Unless, of course, you run across an exception. And they both bring our code coverage up the exact same amount. So whether it's actually testing anything or not, we get passing tests and code coverage results, or code coverage increases. So if all we have is this one assertion, our code coverage is higher, but we have no idea about our code quality because it's not actually being checked properly with the unit tests. So that's why code coverage can be, code coverage can be great, but it doesn't mean that there's actually even any unit tests that do much and actually check the quality of the units of code that they're testing. So this is from Martin Fowler. I think the statement about code or test coverage is great. So test coverage is a useful tool for finding untested parts of code base, but it is of little use as a numeric statement of how good your tests are or how good your code is. Because it doesn't. So I'm sorry, I'm trying to not get on my soapbox. So why should you care about code coverage if it's all so unpredictable, and is it actually helpful? First of all, you need to know how your developers treat the code that they write. Do they even write unit tests? Do they write those pretend unit tests that don't actually check anything? Learn about what's expected, not just from the developers. Do they have code coverage targets that they're supposed to meet? But also what's expected from the code itself. Unit tests will help you understand what is expected from the code, if they're good unit tests. And learn what's in danger. If there's some code that doesn't have any unit tests whatsoever, that is a danger zone. So that is how code coverage can point us to the way of dangerous, riskier areas of the code. If the code itself changes somehow that isn't tested, how will the devs know that they didn't break something? They won't, unless there's exceptions. So if you know that a certain function isn't covered at all and there are some changes kind of in that area, you know you'll need to pay extra attention to it. Essentially, you should care because you'll better understand the state of the code, what the state of the code is when you get it, when it's your turn to get it, to test it. There are a couple of ways to see the code coverage and dig into it a bit more. A lot of developer tools have code coverage extensions built in or downloadable that you can use. This one is Visual Studio with a .NET application. We can see the percentage covered by this class is 19.57%. And we can dig into the individual methods themselves. So how much of this method is covered? Like we have some that are 0% covered. That's not good. That's pretty bad. We can see what is covered and what isn't by unit tests, or how Visual Studio calls it touched rather than covered. Like they are very, they're kind of stepping away from the coverage and seeing if it's touched by tests. So the red indicates that it isn't covered, meaning we don't have a test that checks for that scenario. So this whole thing is not covered. This returning true for is item name valid is not covered. And yellow here means partially covered. So one of our tests covers one of these three scenarios, and blue is covered or touched. So sometimes it's kind of, as long as this method is called, it's automatically covered because it automatically executes. So these colors have varying degrees of visibility depending on your theme in Visual Studio or whatever IDE you have, and of course any kind of color blindness that you have. But there are ways that you can customize the colors if these aren't as visible for you. If we looked at SonarQube for code coverage, we can actually see it in there as well. So again, you don't have to get the IDE installed. You don't have to pull down all of the code. You can look at it through the static analysis tools. So here I can see for the solution and for this utils.cs file, again, 19.57%. And I can actually dig into that file and it shows me, again, it kind of has these indicators that are very similar. This time you have like hovers in case you can't distinguish the colors. I don't know if it's customizable in SonarQube if you can't see these as well, but it gives us kind of the same result. So this is a way that I can see all of this without having to have all of the tools installed. I don't have to have a lot of training. I can just look in here and say, if this is partially covered, if the item name validation is partially covered, I'm gonna mess with that so bad. Like I'm gonna spend some focused testing time on that because I know it's not being tested by unit test properly, and it's probably a mess. So let's look at this method a little bit closely and what tests that we need to be 100% covered. We have one test for empty string. We need to cover null, greater than 255 characters, name, and happy path between 1 and 255 characters. What's missing is we're not checking any of the negative scenarios. Numbers, special characters, Unicode Snowman is my favorite to check for Unicode to make sure that that is supported. It really depends on how name is defined for the class. Like if name is defined as a string, it might be, depending on the programming language, it could be, all of these could be supported, but we don't know. If our requirements had further specifications for what constitutes a valid name, is that here? Is that in the story but didn't show up in the code? For obvious things, we might find them while testing, but looking at code coverage and the actual code helps us, sorry. It gets us looking into the code itself and how our devs are testing their own work. So when we're reviewing PRs, we should be looking at the unit tests as well for all of the code that they have added. And you can add suggestions for that, ways that they can improve their unit tests. So how do you see this amazingly helpful information? Find out what tools your devs are using and learn them. If there aren't any tools, advocate for getting them. This raises code quality by virtue of having visibility into areas that have code smells or are completely untested. If you get pushback or you're not sure it'll work with your leadership, go rogue. I set up SonarQube by myself on my local machine and learned how to use the tools in Visual Studio by using Google, your friend Google, and just find a tool, Google for a tool that'll work with the stack that you're working with and just dive into it. Just click around, figure things out. It's great for information gathering on the code. Dev tools, there are a suite of tools in modern browsers. I don't know about all browsers, but all of the ones that I work with that can really help your testing. They can show you the HTML, CSS, and JavaScript, like everything as it is being executed, the network traffic, performance, cookies, cache stuff, accessibility. There's all kinds of cool stuff in there. The issue we had to troubleshoot earlier, where we had a misspelling in that header, that can access header, and DevTools, once we loaded the page, we would see right away that there's an issue. Honestly, when I am testing a website, I have DevTools open 100% of the time. I'm always watching, especially in the network tab, because sometimes there are calls to other APIs. Maybe you don't notice that it failed. This is actually one reason I had a developer call me a super sleuth tester, because I just had it running all the time, and I saw this third-party API was throwing errors, and we weren't surfacing it, so a user wouldn't see it, but it was generating a lot of problems on the back end. So I strongly advocate for having DevTools open all the time. And with DevTools, we can see the actual request that was made. We can see the 401 that got back. And we can actually see the header, the request header, or the headers that were sent. So we could see this and see that that's a Q. That is very clearly a Q and not an A. So we can say, oh, this doesn't look right. That's an obvious issue. And the best part about the DevTools is that I can help you find issues you had no idea about. So this looks like it's behaving properly. I'm adding a new to-do item, right? If I have DevTools open and I'm doing the same thing, I click add. Look at that error that's showing up in DevTools. In the console, I can see that there's a JavaScript error that the end user doesn't see, but there's a problem. Something isn't working properly. So it's calling back to an API. That API is returning errors. It's just great for all of that. But remember, look for how those errors are handled. If you get a 404 error showing in the DevTools and a pop-up says, we couldn't find your item, that's being handled properly. That's much better than a silent 404. That might not be a bug, so it's all about context. If your app isn't in a browser, you can still use similar tools like Fiddler, Charles Proxy, Wireshark to help you debug some of these things and see the network traffic. Well, we want to use these because they give you a great view under the surface of the application. You're able to see what is actually going on without having to guess. There's a ton of information in there that you can use to inform your testing and help you find invisible bugs. And you get a better understanding of the application because you're able to see the inner workings. Some other tools to dig into potentially: logs, treasure trove of information. If you can get into your logging, you can see those. Occasionally we'll have like error logs show up that we don't have alerts for, but it's a problem. So hey, checking out logs, especially in production, because sometimes stuff will sneak by, nobody says anything, but there's a problem out there. I mean, people are just dealing with it. They think it's like a, something they have to work around. That's something you can get fixed. Monitoring tools. If you watch an application long enough, it does some wacky stuff, and you can put bugs in. Support tickets, if you're not already looking at what your users are finding, what support is telling users to do for workarounds, you need to. People generally don't call support until something is really, really making them mad. So there could be some minor things that aren't surfacing, especially if your users need to pay for support. So keep that in mind. And other people, not necessarily people you consider to be tools, but anyone else that uses your software, sitting with your users or just talking to other people on the team, find what workarounds that they have, things that they noticed that they thought was just them. Some people are like, oh, it's just me, so but sometimes it's not. Sometimes it's a legit bug. So having those natural or formal, it doesn't have to be formal conversations, just conversations about what's aggravating you today about our application. So hopefully you can take this back to work this afternoon. Ways to learn more about the code with commits, PRs, specific static analysis, maybe make some changes yourself to the code if you're getting bold. I've done that before when I'm writing UI automation. I will sometimes, if I have to, pull down the UI code and add the identifiers that I need for the locators or for the elements to make it easier for my automation. I've done that many times. You can spot issues earlier in their cycle by reviewing those PRs, logging the bugs you found by static analysis. Pinpoint the vulnerable areas in the code by understanding what's at risk due to lack of unit tests or duplication of code. You can collect and use a ton of new information from static analysis and dev tools. And that's it. Sorry, we're 5 minutes left. But if anybody has any questions, I am happy to answer them, and I will paste the repo in the chat here. So that is where you can get the slides and a little bit more information. So, any questions?
I guess my quick question is, and it might not be an easy one to answer, but how do you kind of attempt to advocate for getting access when maybe sometimes your repository might have a license fee that is expensive per user, but you're like, I know I'm doing QA, but I really think it'd be valuable for me to get in there. How do you kind of advocate for yourself on that?
That is a great question. I think approaching it from the more information I have about the application under test, the better our quality will be, because I can catch things earlier. We don't have that kind of, especially if you have a throw the code over the wall and test it, and it like a lot of turnaround time for something to be fixed or tested. You can kind of advocate for this will cut that turnaround time because I will be able to see it before it gets to the test environment to make sure that it's good to go. Or just gathering information, because that's, as a tester, I need to understand better what the changes are. And you don't have to say to me, okay, I made this change in this thing, in this code base or whatever, so you can test this. I can just see it for myself. So maybe approach it that way. Like, you don't have to tell me all the changes you're making because I can see them. Or you can say, I'm just really curious. I want to know more about the code. Can you include me in some of those meetings? Like, sometimes that, like, gee whiz, what are you doing? Sometimes that helps.